Hello everyone, welcome to the YOLOv8 crash course. In this course, we will start with installation of Python and PyCharm. Then we will go ahead and run YOLOv8 on video and live webcam feed. We will also see how we can train YOLOv8 on custom dataset. The major part of this course is to integrate YOLOv8 with Flask. We will dive into details how we can integrate YOLOv8 with Flask and test on video and live webcam feed. We will also see how we can create a complete front-end web app, and we will create a complete web app for the personal protective equipment detection project. So let's get started. In the first step, I will just go to python.org and download Python. So I just write python.org and just click on this first link. So now if you just click on downloads, you can see that Python 3.11.3 is the latest release, but I always recommend to don't download the latest release because it have some errors and bug fixes. So just click on all releases from here. So it's always better to download the one down the latest release. Okay, so if we just see the here 3.11 is our latest release. So just download the Python 3.10 version because 3.11 version will have some errors or bug fixes. So I always recommend to download one down the latest release. Okay, so if I just go over here, so you can see that I will just select 3.10.9 Python version from here. And then I will just go down from here and select Windows installer 64-bit, and it's recommended as well, and just click on install. So now you can see that it's being installed. Okay, so now let's just click over it. Okay, so now you can see over here, I will just click on customize installation from here. Okay, and then I will just click pip documentation, idle, Python test suite, everything, and .py launcher as well. Just click over it and then click on next from here, and then just click on install. So I've already installed it, so I will not install it again. Okay, so now in the next step, I will download the PyCharm Community Edition. So to download PyCharm Community Edition, I will just write PyCharm. Just go over here and just write PyCharm download, and then just click on this first link. So now I will just download the community edition from here. We also have the professional version, but as for our need, a community edition is enough, and we don't need the professional version. So in professional version, they offer 30-day trial, 30-day free trial, but we don't require it. And community edition is enough to fulfill our need for this tutorial. Okay, so just click on here. It will download the .exe file. Okay, so the download will start automatically. Okay, now you can see that it's downloading. So I've already downloaded the PyCharm Community Edition. So I will just click on cancellation of this download because I have already installed the PyCharm Community Edition. Okay, so in this way you can download the Python and download the PyCharm Community Edition as well. Okay, so the next step, you will just go to any of your directory and create a folder. Okay, so now you can see that I have just gone to my local disk D directory, and I have created a folder by the name YOLOv8 crash course. Okay, so in this folder, I will place all my project files and everything over here, images, videos, everything will be placed in this folder. Okay, so now in the same way, you can go any of your directory and create an empty folder by any name. Like you can create a folder by your name or YOLOv8, or so I have just created a folder by the name YOLOv8 crash course. Okay, so now you can see over here, I have opened the PyCharm. So I will just click over here, file, click on new project from here. Okay, so I will just now redirect towards the directory where I have just created a folder. So it's inside D. Okay, so now I'm inside the D directory. And here I can see the folder by the name YOLOv8 Crash Course. So this is the folder I just created for this tutorial. So just click over here. Okay. Then I'm just creating a new environment. You can see over here, I'm just creating a new virtual environment over here. And this is my base interpreter python.exe. Okay. So just click over here. So this is my base interpreter, and then click on create new project. As I click on create, it will ask me projects can either be open in a new window or replace the project. So just click on this window from here. Okay. So now it's creating a new virtual environment. You can see over here, and this is our directory name, YOLOv8 Crash Course, which you can see over here. Now we can see that the virtual environment is being created. So this might take few minutes as it's update the interpreter paths and everything. Okay. So now you can see that we have created a new project over here, and here we have the main.py file. So if you just click over here, just right click over here, and then just go to from here. Sorry, just click over here, file, and then click on from here, just click on settings from here, and then just click on over here, project, YOLOv8 Crash Course is the name of our project, and then select click on Python interpreter. So now you can see that these three packages are already installed. So now you can see that we have downloaded Python 3.10. So we can see Python 3.10 over here and YOLOv8 Crash Course. And so just to install any new package, just click over plus and just write here. For example, if I just want to install NumPy, I will just type NumPy and just select NumPy and click on install package. Okay. So it will install the package. So in this way, you can just write all the packages name over here and just install all those packages. Like you can see over here, if I just want to install CV2 package, I will just write opencv -python. So just write opencv-python. So you can see that here we have the cv2.package. So if you just click over here and you can install the CV2 opencv python package as well. But this process takes very much time. Like in this way, you just need to write every single package name over here in the search bar and install that package. There is another way will be also to install the package. So let me just tell you. So now you can see that as I just install the NumPy package, we can see that NumPy package appears over here, and now we have the 4 packages installed. In this way, you can just click over here plus and install any of the package which you require. Okay. So just going back from here. So in order to install the packages of your choice, you just need to click over here, file, and create a file by the name requirements.txt. Okay. So in this file, you can write all the packages which you want to install. So if I just want to install Ultralytics, I will just write Ultralytics 8.0.26. Okay, so this is a version. Okay, in this way, if you want to install NumPy package, although I've just already installed, you can just write NumPy. And if you just want to install matplotlib, you can just write the name of package over here. So now here you can see over here, package requirement, Ultralytics, matplotlib are not satisfied. So if you just click on install requirements, so now it will just install all these 2 packages and just click on install from here. So now you can see that I just go below down over here. You can see that installing package. So it's installing the Ultralytics package, and after this it will install the matplotlib package, although NumPy package is already installed. Okay, so just let's run the main.py file and see what output do we get from here. So if I just click on main.py file and just click on run main and just open that terminal, so you can see that it's giving me the output hi pyjam. So that's fine. In the meanwhile, that Ultralytics package get installed, and let me tell you, in this video tutorial, I will be using YOLOv8 for the object detection. So so to implement YOLOv8, we just need to install the Ultralytics package, which I am just installing over here. So YOLOv8 is the latest release of the YOLO version. So YOLOv8 outperforms all the other YOLO version in terms of accuracy and speed, and the mean average precision of 57.6 has been marked with YOLOv8. So if I just show you the YOLOv8 GitHub repository, so let me just show you. So if you just click over here and just write YOLOv8 GitHub, okay. So and just click on this first link. So Ultralytics has released YOLOv8. Ultralytics has also released YOLOv8 and YOLOv8. So YOLOv8 is the only version of YOLO which has its own package. So you just need to install pip install Ultralytics and you can just run YOLOv8. So YOLOv8 is the only version of YOLO which has its own package. Like you can see over here, pip install Ultralytics will just install the YOLOv8 on your system, and you just need to write YOLO predict and you can just run YOLOv8. Okay. So prior versions of YOLO don't have their own package, but YOLOv8 has its own package, which is pip install Ultralytics. So using pip install Ultralytics, you can just install YOLOv8. You can also, if you want to make any change in the detection or training script, you can just clone the repo as well. Okay, so here in our case, we are just installing the YOLOv8 package by just writing Ultralytics and its version, okay, in the requirements.txt file. So if I just go back over here, now you can see over here in the requirements.txt file, I am just installing YOLOv8 by just writing Ultralytics and its version. So in this way, we can install the YOLOv8. So now we can see that package is successfully installed. Packages Ultralytics and Matplotlib package has been successfully installed. You can see in the note over here below down, like the package installed successfully, which includes Ultralytics and Matplotlib package. And you can see that we are using Python 3.10, which you can see over in the top, in the bottom right corner, Python 3.10, which we are using, which we have just downloaded the Python 3.10 version from python.org. Okay, so now we will just run YOLOv8. So first of all, I will just go over here and click on new and create a directory by the name running YOLOv8. Running YOLOv8. Okay. So this is our directory running YOLOv8, and here I will just create a file by the name YOLO test.py. Okay. So now you can see that as we have installed the Ultralytics package, so I will just write from Ultralytics import YOLO. Okay. So it will import YOLOv8 from by using from Ultralytics import YOLO. It will automatically import the YOLOv8. Okay. YOLOv8 package from Ultralytics. So in the next step, I will just write import cv2, or let's just skip it and just write model is equal to then we just need to write YOLO and just write in case of in YOLOv8 we have different weights available. So let me just show you. So now if I just go below down here, so now you can see that we have 5 different weights. YOLOv8N or nano is the smallest, and it is the smallest in size, and it is the fastest as well, but it is less accurate. While YOLOv8X is the more accurate, but it is less fast, or it is slow as compared to other YOLOv8 versions. So simply YOLOv8N is less accurate, but it is the fastest. But YOLOv8X is more accurate than all other YOLOv8, but it is less fast. Okay. So just go back from here and just write YOLOv8n.pt. Okay, so I'm just writing the name of the weight file over here. So the weight will be automatically downloaded. Okay, so we don't need to manually download the weight and just place in this folder. The weights will be automatically downloaded. You just need to write the name of the weights which you want to use. Just need to write the name of the weights, pre-trained weights over here. Okay. And then after this, write results is equal to model and just pass the input image path over here. Okay, so let me just okay, so let me just add some image over here. So I already have downloaded some images from Google. So I will just add these images over here. So let me just go back and just let me add some new images. Okay, So just give me a minute. I'm just going back and just adding some new images. Okay, so let me just show you as well. So if I just go over here in this folder, so now in the images folder, you can see over here, I have just placed these 4 images. Okay, so let me just test out on these images and see what results do we get. Okay, so I'm just going back towards the code and I will just write out down. So I will now, I just want to go to the images folder and just write the name of the image or the image path. I just need to add the image path. So I will just write dot dot, which means go backward, like go outside this running YOLOv8 folder and then just go to images folder and just write the 3.png, the name of the image on which I was want to perform the detection. Okay, and just write show is equal to true. Okay, so now just click on over here yolo-test.py. So just click over here and just run yolo-test this script. So I'm just running this yolo-test.py script. Okay, so this might take few seconds. Now you can see that the output just appear and it just close because we don't have added any delay. Okay, so that's why we cannot see the output. It just appeared and went away. So because we don't have added, because we haven't added any delay. So let's add the delay. So to add the delay, I will just import CV2. Import CV2 and I will just write CV2 dot wait key. So I'm just adding the delay now and just write 0 over here. And now let's run this script again. So now hopefully we will have the output in front of us. Okay. Previously, we can't see the output because we don't have any added any delay. So now you can see that we have the output in front of us. Like you can see that this is the input image I have just passed. And here we have the detection results using YOLOv8. So now you can see that the model is able to detect motorcycles. Like you can see that here we have multiple motorcycles. Plus in the back side of the image, we have the cars. So the model is able to detect cars as well as the motorcycle. So the detection results are quite fine. Let's test on some other images as well and see what results do we get. Okay. So just write another name. So I'm just passing 2.png and see what results do we get. So just click over here and just run YOLO-test. And okay, I just forgot to stop the previous. So I will just click over here and stop the previous running script and just run this again now. So run YOLO-test. Okay. Okay, so let's see what results do we get in this case from here. Okay, so let me just share my screen now. So now you can see over here, like you can see over here, we have detected a car. This is a wrong detection. This is not a bus. This is also a car. While you can see that the YOLOv8 model is detecting cars and these are very impressive results. Currently, we are using YOLOv8 Nano, but I have already told you that YOLOv8X is the largest among the YOLOv8 model and it is more accurate. So you can also use the YOLOv8X weights, and in that, if you use the YOLOv8X weights, the detection results will be more good because YOLOv8 and Nano is although the fastest, but it is less accurate, while YOLOv8X is less fast, but is more accurate. Okay, so the detection results are fine. So let me just go back. Okay, so now what we can do is we can test on some other images as well, but I have already tested on 2 images, 2.png and 3.png already. So now we will run YOLOv8 on webcam and see what results do we get. So I will just click over here and create a new directory by the name running YOLOv8 webcam. Okay, so now we will be running YOLOv8 on the webcam. So just create a new folder over here, YOLOv8 webcam.py. Okay, so I'm just created a new file over here, YOLOv8 webcam.py. And first of all, I will just close the previous ones. From Ultralytics, import YOLO. Okay, so we have just imported the YOLOv8 version over here. Then I will write import CV2. Then I will just write import math over here. Math. Currently, just remove this. I will just explain this as we go further on. So okay. Then just write cap is equal to CV2 dot video capture. And just write, as I just want to run a YOLO on V8 on my webcam, so I will just write 0 over here. But if you have multiple webcams connected to your system, then you can just check which webcam are you using. It can be 1 or 0 in any case. Then I will just calculate the frame width over here. Okay. So to get the frame width, just write int cap.get 3, and to just get the frame height, just write frame height is equal to int cap.get 4. So in this way, we are just getting the frame width and the frame height. If I just want to save the output video with detection, I will just write out is equal to cv2.videowriter and just write the name output.avi. This is the name, the name of my output file. Like after doing the detections or after doing detection on video or using webcam, the output video will be saved by the name output.avi. Then I will just write cv2.videowriter dash for cc and just write m over here and comma j comma p g. Okay, then just pass the frame rate over here and then just pass the frame width and frame height over here. Okay, so just to find my output video writer function over here using cv2.videowriter, then just click on enter and just write model is equal to YOLO. And if I just go to the YOLOv8's for YOLOv8's folder over here, you can see that here we have the YOLOv8 and our pre-trained weights placed over here. So just write ... and just say that go towards the we just need to get out of this running YOLOv8 webcam folder and just need to go to the YOLOv8's folder. So just write YOLO-weights. Okay, and just write YOLOv8 and .pt over here. So here I'm just passing the pre-trained weights path over here and just click on enter over here. Then just write while true. Okay. Success is comma image is equal to cap.read. So we are just reading frame by frame. Okay. Okay, so let's just test this. Either our webcam is working fine or is there an issue? So just write cv2.imshow image comma image over here and just write cv2.wait key over here and just click over here 1, and I think that's fine. Or just further elaborated, cv2.wait key is 1 and order is equal to 1, then break. Okay, so that's completely fine. So let me just run it and see if I am able to access the webcam or not, and if I'm able to save the output video or not. So let's just click over here and click on run YOLOv8 webcam. Okay, so let me just, I think it might take few seconds for it to appear. So let's just wait. Okay, I don't think any error. Okay, let's just navigate my screen over here. Just give me a minute. So now you can see over here, the webcam is working fine. Now you can see my image on your screens. Okay. So I think the webcam is working fine. Let's see if this output video is being saved into the directory or not. Okay. So let me just go back over here. Okay. So now you can see that here we have the output file has been created over here. But let me just go back from here and just let me just pause, stop this process by just clicking over here. Okay, and let me just see if the output video is working or is there an issue. So just click over here. So now we can see that our output video is being saved. Okay, so now you can see that as when we run the webcam, our video is being saved. So that's fine. That's perfectly fine. Okay, so let me just go back towards the code. So now, now I will just add I'm now using YOLOv8 model, which I've just called over here and just saved in the variable model. Now I will just run the detections on the live web feed. So let me just add that code over here and run detection on the live webcam feed as well. Okay. So here I have just written the complete code. So let me just explain you the complete code over here. So now here you can see that we are just doing the detections using YOLOv8 model on frame by frame. So here we have set the stream is equal to true. So stream is equal to true, we'll use the generator and it is more efficient than the than if we just don't write stream is equal to true. Okay, so we are doing detection using YOLOv8 frame by frame and our results are saved in this variable results. So once we have the results, we can check for individual bounding boxes and see how does it performs. So here you can see here, once we have the results, we can check for the individual bounding boxes and see how well it performs. So we will just look through each of the bounding boxes and for each of the result and see how our detections are performing. Okay, so now you can see that here we are just looping through each of the individual bounding boxes. You can see over here. So here we have the x1, y1 coordinate of the bounding box, and here we have the x2 and y2 coordinate of the bounding box. So let me just show you how does basically it works. So let me just open the paint over here. Okay, just give me a minute. I'm just opening it. So for example, if we have this bounding box, okay, so you can see here we have the 4 coordinates for each of the bounding box. Let me just write over here. So this is the x1, y1 coordinate, and this is the x2 and y2 coordinate. Okay, so for each of the bounding box we have the x1 y1 coordinate and this is the x2 y2 coordinate. So x1 y1 is the, like you can see that at top left corner coordinate, and this x2 y2 is the bottom right corner coordinate. Okay, so if you just go back towards the code again. Okay, so now you can see here for each of the bounding box, we have the x1, y1 and x2, y2 coordinates. Okay, that's perfectly fine. If we just go over here, so now you can see that we are just converting these coordinates values to integers. Why we just need to convert this coordinate value to integers? Because the output which we are getting over here is in the form of tensors. We need to convert this output into integers. So let me just show you what kind of output we are getting, and after converting into integers, what kind of output do we get. So just run this from here and just let me just show you the output which we are getting. The webcam is just currently on, so it might take few seconds to just make the webcam working. So okay, so now you can see over here we have the output in the form of tensors. But to further process this and create bounding boxes around the detected object, we need to convert this output from tensors into integers. So now we will just convert this output from the tensors into integers. So to convert this output from tensors into integers, So just comment this out from here. And so just you need to write int x1, y1. So we are just converting each of the coordinate from tensor into integer. So now just run this again and see what output do actually we get. So now basically our output is being converted from tensors into integer over here. So we will have the output very soon for over here. Okay. So now you can see over here, now we have the output in the form of integers. Though we can't see the tensors over here, you can see that we have the output in the form of now integers. So let me just pause this from here. So now you can see that previously we have the tensors around each of the coordinate, but now we don't have the tensors around each of the coordinate. We have the output in the form of integer 4, 0. These are the x1, y1 coordinate value. This is the x1 coordinate value. This is the y1 coordinate value. This is the x2 coordinate value. And this is the y2 coordinate value. Okay. So now we just need to create a rectangle over here. So we using, or you can say that we need to create a bounding box around each of the detected object. So basically we have the coordinate value for each of the detected object. Like we have the coordinates value for each of the detected object. We just need to create a rectangle around each of the detected object. So using cv2.rectangle, we will create a rectangle around each of the detected object. Okay. So if I just go over here and show you what are the parameters we have in cv2.rectangle. Okay, so let me just open this from here. So, okay. Okay, so now you can see over here in the cv2.rectangle, we just pass the our image or the current frame. Okay. And then we have the starting point, and then we have the ending point and the color of the rectangle, and then we have the thickness. Okay. So now you can see over here, if you just see this, so this is our starting point. You can see over here, this is the ending point. Oh, and we will just define the color and the thickness of this bounding box. So if I just go back towards the code, so now you can see over here, we have, this is the current frame, and this is our starting point. This is our ending point, and this is the color of the bounding box. It's around pink, and this is the thickness of the bounding box. Okay. So let me just comment this out currently. Let me just display the bounding boxes first, and then we will discuss the rest. Okay, so I'm just currently focused on displaying the bounding box. I'm not interested in displaying anything else. Okay, so let me just display the bounding boxes and see what results do actually we get. Okay, so let me just, I'm just checking few things over here if there is an issue, so I can just correct it. So let me just comment this out currently as well. Okay, so let me just run this and see what output do we get. Are we able to draw bounding boxes around a detected object or not? So currently our goal is to draw bounding boxes around each of the detected object, and then we will go ahead and see further. Okay, so now you can see that a bounding box is being drawn around the, as I'm a person, so a bounding boxes are drawn around B. So that's perfectly fine. That's what we are expecting. You can see over here, a bounding box is being drawn around B. So this is the output which we expect basically, that a bounding box should be drawn around each of the detected object. Okay, so this is our expectation. But now we just want to have the label and the confidence score as well. Like label means if I'm a person, there should be shown that I'm a person label. Above the bounding box, there should be a label that I am a person. And the confidence score, like how much our YOLOv8 model is confident that I am a person. So I have already told you, as our YOLOv8 model, we are just using the YOLOv8 pre-trained model, which is trained on Coco dataset. So the Coco dataset consists of 80 different classes. So I've just written the name of all those classes over here. These are all the classes which we have in the Coco dataset, which are around 80 different classes. Okay. So to get the confidence score over here, I'm just passing this using bad.seal. We are just getting the confidence score values. The confidence score basically appears in the form of tensors. Okay, so to just convert into integer, I'm just using this mat.seal. Let me show you what originally we have the confidence score value. So just write print box dot confidence, okay, and just write 0. And let's see what does the value confidence score value do we get. So then we will discuss later, few things later. So just comment this out currently. I just don't want to show the output currently. I just want to show you the confidence score value. So just click on run YOLOv8 webcam. So now we'll have the confidence score value over here as well. So this might take few seconds. So now you can see here. Okay, so just let me just stop this. So now you can see that we have the confidence score value in the form of tensors. We just need to convert this value into integers. So I'm just converting this value into integers over here. Okay. Plus, now you can see over here, we have the confidence score value into it. We are just converting the confidence score value into integers. And now using int box.cls0, we are just getting the class ID. Okay. So here CLS will give us the class ID, and here I've just written the class name. So if the class ID is 0, it means it is a person. If the class ID is 1, it means it is a bicycle. And if the class ID is 2, it means it is a car. Okay. So here I'm just getting the class ID, and here that I'm just finding the class name, and in the label I am just putting the class name and confidence value combined. And here I'm just finding using cv2.getTextSize function, I'm finding the size of this label. So I can just create a rectangle, fill rectangle as per the size of this label. And here I'm just creating a rectangle above the bounding box, so that I'm just put text around it. Okay. Okay. And I'm just saving my detections in the in the file name as output.avi. In this output.avi file, my detections will be saved. And just let me just show you the detections frame by frame live. And if I just click on 1, the process will stop. And just clicking on auto release. So let's just run this and see what results do actually we get. And is our output saved or not? Output detection video saved or not? So just run YOLOv8 webcam and see what results are we getting now. Okay, so this might take few seconds more. So now you can see that over here, the label person as well. Plus you can see over here the confidence score over here as well. Plus on the back side, I have the sofa. So you can see that sofa over here as well. Plus you can see that a bounding box is created around me, and I am a person. So you can see the person over here. Plus on the back side, you can see the sofa, and you can see the label sofa over here as well. Okay, so let me just remove this. You can see that sofa and so the detections are very well. You can see over here. So these are the results which we expect, and this is all from this. Let me just show you if our output video is saved or not. So I'm just stopping this video and let me show you if our output video is saved or not. So let me just go YOLOv8. Okay, so let me just go towards the YOLOv8 crash course, run YOLOv8 webcam. And so you can see over here, here we have the output video. So if I just click over here, okay, so now you can see that the results are very impressive. Our output is being saved. You can see over here. Okay, so you can see that we are able to do the detections on the live webcam, and our output video is saved here as well. So that's perfectly fine. That's the results which I am expecting, and that's pretty impressive. So in the next video tutorial, we will run YOLOv8 on Windows and see what results do we get. So now we will see how we can run YOLOv8 on Windows. So first of all, I will just click over here, click on new and create a new directory and just write running YOLOv8 Windows. Okay. So I've just created a new directory by the name running YOLOv8 Windows, which you can see over here. And I've just click over here, click on new and create a file YOLOv8-video.py file. Okay, so I will just copy the code which I have in the YOLOv8 webcam.py file and just paste this code into the YOLOv8 dash video.py file. So what change I will make before explaining that change, what I will do is I will just go to over here and let me show you a video, sample video. So I have just created a folder over here by the name videos, and if I just open this folder, you can see a video bikes.mp4. So now I will just perform detection on this video and I will see whether my model is able to detect the person and the bicycle over here or not. So what I expect is that my model should be able to detect the person and the bicycles, because I'm using YOLOv8 pre-trained weights, and the pre-trained model is being trained on the Coco dataset, which can detect 80 classes, and among those classes we have the bicycle and the person class as well. Okay, so just close this out, and in the cv2.video capture 0, just pass the this path. So I will just write ... It means we just need to go outside this folder running YOLOv8 Windows or running YOLOv8 videos. I think this should be the name of this folder should be YOLOv8 videos, but now I've just created it. So we just need to go back to this folder, from this folder, and just go to the videos folder. Just write videos, and in the videos, I will just select bikes.mp4. Okay, so bikes.mp4. So just select this out from here by just writing dash. Okay. Okay, so I think that would work perfectly fine. Okay, so I'm just using the bikes.mp4 and redirecting towards this directory. Okay, so let's just run this and see what output do we get. So just click on run YOLOv8 video. So I'm just running this script file, and let's see what output do we get. If there is any error, we will definitely fix it out. So now you can see over here, we are able to detect the bicycle as well as we are able to detect the person. We have the confidence score along with this as well. So the detection results are quite impressive. Like we are able to detect the person. We are also able to detect the bicycle. We have assigned the label bicycle. We have assigned the label person, and the confidence score we also have over here. Okay. So that's perfect. Like you can see over here, we are also able to detect the traffic light over here as well. We have created a bounding box around it as well, and the results look quite impressive. In short, you can say that these are the results what I was expecting, and amazing. So let me just stop this video and see if my output video is saved, output detection video is saved into this folder or not. So I will just go over here, run YOLOv8 Windows, and this is the output.avi file, which contains the output video with detections. Okay, so now you can see over here, we are able to do detections. Like you can see that we have created a bounding box around the bicycle. We have also created a bounding box around the person as well. Like you can see over here, we are able to do detections. Plus, we have also assigned the confidence score and the label as well. So the results are pretty impressive. Okay, so now till now we have done detection on images, videos, and on the live webcam feed as well. So we have covered half of the part. Like we have from the start, we learned how we can install Python, how we can install the PyCharm Community Edition, how we can run YOLOv8 on images. We have also seen that how we can run YOLOv8 on videos, and how we can run YOLOv8 on webcam as well. So in the next part, we will integrate YOLOv8 with Flask. Okay, so let's see you all in the next part. So now we will see how we can integrate YOLOv8 with Flask. So this is all the code which I have already written and explained you previously. But one change which I have made is that I have just created a function video detection and added all this code inside this function video detection. Okay, and in the end of this function, or the output of this function, is the output image or the frame with the bounding boxes around the detected object with labels and the confidence score. So this is that you can see here in the yield we have the image or the current frame with output bounding boxes around detected object with the labels and the confidence code. So now plus I have just created a file by the name flask.app.py file. So let's start from the start. So as we are integrating YOLOv8 with Flask, so in the first step, you need to make sure that you have installed Flask on your system. So if you have not installed Flask on your system, just install it by just writing pip install Flask. Okay, so this will install Flask on your system because uh, we are creating a web app using Flask. Okay, and we are just integrating YOLOv8 with Flask to create a web app. So as I've already installed the Flask, so you can see over here the requirements already satisfied. But if you haven't installed Flask already, it will take some time to install. Okay, so then we are just importing from Flask, import Flask render dash template. So why we need to import render dash template is that we need a render dash template to render our HTML file, but we are not using this currently over here. So you can just remove this from here, like this session request JSONify response. You can remove this render dash template currently because we are not using it. Plus, you can also use this session because we are not saving the video file path in the session storage. We will do this later on. Thus, you can see simply remove JSONify as well. We use JSONify when we want to convert our output like frame rate or the total number of detections into a JSON format to display on our HTML page. Then if I go ahead, I'm just importing CV2. So CV2 library is required if you want to run the YOLOv8 model. Then I'm just from the YOLOv8-video.py file. From this file, I'm just importing the video-detection function. So now you can see here in this YOLO-video.py file, I have this video-detection function. So I'm just importing this function. And here I'm just initializing Flask. You can see here. And here I'm just creating a secret key, which I've written by name. You can just change it as well. So now here we have the generate frames function. So generate frame function take path of input video file and gives the output with bounding boxes around detected object. So here we are just creating a function by the name generate frame. So this in the path-x, we will just pass the input video file path and it will give us the output with bounding boxes, labels, and the confidence score around each of the detected objects. Okay. So now here I'm just calling the video detection function. And so now you can see here we have the video detection function, and in the video detection path function, we just pass the path of the input video file. Okay, so here I'm just calling the video detection function. So the video detection function will give us the output. The video detection function will give us the bounding boxes around the detected object with labels and the confidence score. Okay, so as we are doing detection frame by frame, okay, so now you can see here we are just encoding the detection. So basically any in-Flask application requires the encoded image to be converted into bytes. So we are just encoding the current frame of the video. So basically any Flask application requires the encoded image to be converted into bytes. So here you can see over here, we are just converting the encoded image like you can see here, or the encoded frame into bytes. You can see over here using .2 bytes. I'm just converting the encoded image or the frame into bytes. Okay. So now we will look over all the individual frames and display them as video. So now we will look each. So basically our video is divided into multiple frames. When we run object detection on the video, the complete video is divided into multiple frames and we do the detection on each of the frame one by one. Okay. So after doing detections on each of the frame, so you can see here, we will look over all individual frame and display them as video. So after doing detection on each of the frame one by one, now basically we want to display our output as a video. So when we want the individual frames to be replaced by subsequent frames, like in the form of video, the content type or mini type will be used. So now you can see here, we are just using the content type because we just want to replace the individual frames detection by the subsequent frames. Okay. And so you can see over here, here we are just using the yield keyword, which you can see over here. So using yield keyword, we will after using yield keyword, in the video detection function output, we will get the individual frames with bounding boxes around the detected object along with the label and the confidence score. Okay, so this is all. So again, just explaining the generate frame function. In the generate frame function, we just pass the input path of our input video file. Okay, and here I'm just calling the video detection function. So video detection function will give us the output with bounding boxes around the detected object. And here we are just encoding our frame. And so basically, any Flask application required the encoded image to be converted into bytes. So now you can see over here, we are just converting the encoded image into bytes using .2 bytes. And basically we will loop over all the individual frames and do the detection on each of the frame as one by one. And then we will replace the individual frame by the subsequent frame using content type or mini type. Okay. So this is all. And then I'm just calling this using app.root method. I'm just creating a URL dash video. So using app.root method, I'm just creating a URL dash video. So in the dash video, I'm just creating passing generate frames, calling this generate frame function in the response. I'm just calling the dash video URL. I'm just calling the generate frame function. And in the path dash X, I will just pass the path of my input video file. So just remove this. Here you can see on here, you can see that here I've just passed the path of my input video file. So currently I'm just in this folder, Flask tutorial YOLOv8. So I've just written dot. So just go out of this folder, get out of this folder and just go to the videos folder. And in the videos folder, I have the bikes.mp4. So I'm just going to the videos folder and here I have the bikes.mp4. So as I already told you to, when you want to the individual frames to be replaced by subsequent frames, we either use mini type or content type. Okay. So here I'm just using MIME type multipart to replace the individual frames by the subsequent frames. And here I've just passed the path of my input video file and just now run this Flask app.py file and see if we are able to integrate Flask with YOLOv8 and how our results look like when we just call the URL dash video. So just need to go to the terminal and if you just click over here and just click on copy path and just write cd, like we want to set this path as our current directory. Okay, and just go over here, copy path and just copy this absolute path. Okay, and just write cd and just add this path. Now just write Python and just run this flask app.py, flask app.py and just click on enter now. Okay, so now basically we are integrating YOLOv8 with Flask and currently I'm just running on a video basically. So just click on this URL. So basically this is not our URL. Basically we have created a URL dash video. Okay, so we have not created a root page yet. We have just created a URL dash video. So just click over here, dash video and just click on enter. So now you can see over here, we are just doing the detections on our input video, which I have passed. Okay, so now you can see that we have the bounding boxes around the detected object, like around the person, we have the bounding box and we have the label person and the confidence score. Around the bicycle, we have the bounding box and we have the label bicycle and the confidence score over here as well. And on the traffic light, we have the bounding box around the traffic light, we have the label and we have also have the confidence score over here as well. So the results look impressive. So now you can see over here, we have integrated YOLOv8 with Flask. And now when I call this URL dash video, it do the detections on the input video, which I have passed over here. So this is the input video, which I have passed. And let me just show you this video. So if I just go to my folder, YOLOv8 course. Okay. So if I just go to video, so I'm just passing this video as my input. So, and here the detection is done on frame by frame. So now you can see that I'm just using this video to do the detections. Okay, and you can see over here, I've just passed this video as my input video file in the flask app.py file, and we can see that we are able to do the detections of bicycle, person, and a traffic light. So you can pass any video path of which you want over here and you can do the detections on it as well. So now we have done detections on a video. Now in the next video tutorial or in the next part, we will see how we can do detections on a live webcam feed. So how we can create a Flask API so that we can do detections on the live webcam feed. So let's discuss in the next part. In the previous part, we have seen that how we can integrate YOLOv8 with Flask and run on a video. So now we will see that how we can run on a live webcam feed. So to run on the live webcam feed, just change in the video path in the path-x to 0. So I will just comment this out. And in this, if I just uncomment it, so now you can see over here in the path-x, I have just entered 0, and I have just removed this path of the video path. I will have just removed the video path from here and just replaced it with 0. So by replacing this video path with 0, we will be able to run this on the live webcam feed. So in the previous video, we have already seen that how we can integrate YOLOv8 with Flask. So by just replacing the video path with 0, we will be able to run this on the live webcam feed. So just write Python. Just for now, just run this script Python flask.py file, and now we will be able to run this on the live webcam feed. So this might take few seconds as well. So let me just click on this path. Okay. Before I just run this, let me just stop this from here, and instead of doing this, let me just comment this out and uncomment this. Let's create a newer URL to run this on live webcam feed. So just copy this from here and just write here webcam and just replace this path with 0. So if we just replace this path with 0, we will be able to run this on live webcam feed. So I've just replaced the video path with 0. So instead of just accommodating into the video URL, I have just created another URL by the name webcam. So here using app.root method, I have just created a URL webcam. So, and just in the path-x, I have just removed this video path and added 0 so that I will be able to run this on the live webcam feed. So just run this now. So now when I can just call this URL -webcam, I will be able to run this on the live webcam feed and do the detections. So what is the error? Okay, so we just need to change this function. We cannot have two functions by the same name like video webcam. So now just run this again. So now we are just running the Flask app.py file. So now we will see that if we are able to do the detections on the live webcam feed or not. So just copy this URL from here, copy URL and just go over here and just write this and dash webcam and see if we are able to do detections on the live webcam feed or not. So let's see how does it work. So I'm just also waiting with you. So now you can see over here, we are able to do detections on the live webcam feed. Okay, so you can see over here, you can see that around bounding box around B and the label person with the confidence score here as well. Just go a bit away and see that now you can see here on the back side, I have the sofa and it's detecting as the sofa. Okay, and here I have the tab is able to detect the tab or not. Let's see. So now you can see over here, it's detecting the tablet as the laptop, although it's a tablet. So that's okay as well. So now you can see over here, it's working quite fine on the live webcam feed as well. We can see that around the bounding box around me and the label as well. So the results are good. Okay. So now you can see over here, we are able to run this on the live webcam feed as well. And the results are quite impressive. So if you guys want to run on video, so just need to go over here and or just refresh this URL we have already added. So I will just refresh this dash video URL and see if you are able to do the detections on the video or not. So now if I just call this dash video URL, you can see over here, we are able to do the detections on the video. So you can see over here, we have drawn the bounding box around the person with the label. and the confidence score. And we have drawn the bounding box around the bicycle with the label bicycle and the confidence score over here as well. So that's quite impressive. We have also detected a traffic light. We have drawn the bounding box, and here we have the label traffic light. So now you can see over here, we are detecting that car, and we have a label car, and we have the confidence score over here as well. And here we are just detecting the person, and we have the confidence score. And here we are also detecting the motorbike. We have the label motorbike and the confidence score as well. So now we have seen that how we can integrate YOLOv8 with Flask and do the detections on the video on live webcam feed as well. So we have integrated YOLOv8 with Flask, and I was able to do detections on video and on the live webcam feed. So now in the next video, we will see that how we can create an HTML page and make this more like how we can further polish this and create a complete HTML web page and do the styling using CSS. So see you on the next part. So till now, we have seen that how we can integrate YOLOv8 with Flask. So now we will create a complete web app. So for the front end design, I will use HTML and CSS, and for the back end, I will be using Flask. So let's get started. I have already done the complete code. So I will explain you step by step the complete code. But before we go towards the code, let me show you how our web app will look like. So if I just go to templates, so our web app will consist of 3 different pages. One is the home page, and the other 2 pages, let me show you. So if I just click on index project, so this is our root page or home page. So let me just open this. So now you can see over here, this is our web app home page will look like. So this is the home page of our web app. So you can see over here, we have this is our header, and here you can see that I have added some sample results from my different projects. Okay, and here we have the content page, and here we have the footer. So if you just click over here, it will redirect towards my YouTube channel. Okay, so this is how it all looks like. So in the home page, you can see that we have the video and live webcam. So this is my home page. This is the root page or home page. If I just click on video, it will redirect me to the video page where I can just upload the video and run YOLOv8 detections on that video. And if I just click on live webcam, it will redirect me to the live webcam page where my webcam will automatically turn on, and I can do the detection using live webcam, or it will do the detections on the live webcam feed. Okay, so this is the home page, and let me show you the other 2 pages as well. So when the users click on the video tab in the home page, like the user click on this video tab, it will redirect it to this page, which is over here. So here the user will upload the video and then click on submit, and in here in this screen you will see the live detections or detections on that input video. Okay, okay, and if the users go to the here and just click on live webcam, okay, so it will redirect him to the live webcam feed page. So it will be the user will be redirected to this UI.html page. So here our webcam will be automatically turned on, and you can see the live detections over here. Okay, so this is how it all works. So we have created 3 web HTML pages. One is this home page, and if the user if your user wants to test his YOLOv8 model or any custom model on any video, the user will click over here, and he will be redirected to this HTML page. And here the user will upload a video and then click on submit, and he can see the detections on that input video over in this screen over here. And if the users want to do detections on the live webcam feed, he will click over here, and the user will be redirected towards this live webcam feed page. And the users, if you are just testing on the live webcam, if you're using laptop, your laptop live webcam will be turned on, and you can do the detections on the live webcam feed. Okay, so these are our 3 HTML pages, and this is our home page. This is our live webcam feed page, and this is our, if the user wants to test on some video, this in this page at this page HTML page, he will upload a video and do the detections on that input video. Okay, so this is the Flask app.py file over here. If you can see over here, and these are our 3 HTML pages. So let's just focus on Flask app.py, and then we will discuss these HTML pages later on. Okay, so now you can see over here, from here you can see that I'm just importing Flask. So just remember, if you haven't installed Flask previously, you need to install Flask by just writing pip install Flask over here. So you just need to write pip install Flask if you haven't installed Flask already. Okay. So I have already installed the Flask, so you can see that requirements are already satisfied. But if you haven't installed it, it will take some time. Then you can see that we are importing Flask form. Flask form is basically required to receive the input from the user. Okay, so when uploading a video file to our object detection model, so where we are using Flask form. So if you just go over here, if you just go to our video page, okay. So now you can see here the user will upload a video, okay, and then we'll click submit. So to allow the user to upload a video, we are using Flask form, okay. So Flask form is Flask form. It is required to receive input from the user. To receive the input from the user in the form of video file .mp4 file, we require the Flask form, okay, so that user can upload a video. Okay, so then we are just using submit field, string field, integer range field. So why I'm just using integer range field, so that we use the integer range field. Okay, let me discuss this integer range field later on, because later we will be using it. Plus you can see here from wt forms.validators import input required. So here we are just using validators. So to validate that the user upload the video file and it is in the correct format. So for example, like you can see over here, the user, when the user uploads a file, video file over here, we want to make sure that this is the mp4.avi file. So, okay, it should be a video file. It should not be an image or some PDF document. To make sure that a user uploads a video file in mp4 or .avi format, we require validators to make sure that the user uploads the video file and it is in the correct format. To make sure that the user uploads the video file and it is in the correct format, we require the validators, so that user upload a .mp4 or .avi file. The user should not upload a JPG or PNG file, image file, or a PDF document or some other Excel sheet. The user should upload a video file, or it should be in the mp4 or .avi file. To make sure, we require the validators. And to run the YOLOv8 model, we are just importing cv2. And if I just go over here, YOLO-video.py, here we have the video detection function. So we are just importing this video detection function from the YOLO-video.py. And here we are just initializing Flask. This is the requirement of Flask. And here I'm just defining a secret key, Muhammad Moin. You can define the secret key by any name. And here I'm just defining the static files. So basically, when the users upload a video file over here, when the user upload an input video file over here and then click on submit, so that the detection can happen on this video. So when the user upload an input video file over here, that input file will be saved in the static files folder. Okay, so whenever the user upload any file, video file, that video file will be saved in the static files folder. So any input video file will be saved in the static files folder. So now, as I told you that we use the Flask form to receive the input video input from the user. So use Flask form to get input video file. Okay, we don't need the to get the input video file from user. Okay, so we are using Flask form to get input video file from the user, and we have created a class upload file form. So we are stored the uploaded video file path in the file field in the variable file. So yeah, you can see over here in the file field, in this variable file, we store so if the user upload any input video file, the file path of the input video file will be stored in this file variable. So the file path of that input video file will be stored in this file variable. And here you can see that we are just calling the validators to make sure that the user upload a input video file and it is in the correct format. Okay. So we have added validators to make sure that user inputs the video in the valid format, and user does not upload the video when, and user does upload the video when prompted to do so. Okay. So just remove this, we don't need it. And then we have the submit button, so that user can just submit the video file and we can do the detections on that input video file. Okay. So now here again, we have the generate frames function. Okay. So generate frame function is same, like you can see that we are just calling the video detection function, which we have in the YOLO-video file. So the video detection function will give us a detection on the detection will in the detection we have the output bounding boxes. We have the bounding boxes around detected object. So in detection, so again just show you, in the video detection function will give us the output image which contains the bounding boxes around the detected objects with label and confidence score. So in this detection dash we have the bounding boxes around detected objects with label and the confidence. So now we are just encoding the front frame, and so as basically Flask requires the input image to be converted in the form of bytes. So we are just converting the image or the current frames to be converted into bytes using .2 bytes. We are just converting the image or the current frame .2 bytes, because it is a requirement of Flask that the input image or frame should be converted into bytes. Okay. So here we are choosing content type to convert the individual frames into a subsequent frame so that it looks like a video. Okay. And then we have the generate frame web. So we just call this function when we just want to access the web cam or we just want to run the detections on the webcam. We just call this function generate frames web. Okay. And then you can see over here, we are just using app.root method. I am just creating a URL dash. So what does it reflects that? So whenever this URL is called, we will redirect it towards the home page. Okay. So if, for example, app.root dash or dash home will be called, we will be redirected towards the home page of our web app. Okay. And now you can see here, we are just doing the session.clear. So what does session.clear does is that we are just so if we have some, if we have tested on some input video, we have run detections on a video, input video. So we are just clearing the session. Okay. So that whenever we want to test on some other video, the previous input video which we have passed, the detection should not happen on the previous input video. So we are just clearing the session storage and removing the input video file paths from the session storage, because we when we upload a new video or rerun the web app, the detection should happen on the new video which we have uploaded, not on the previous video. Okay. So now we are if the URL if the users, now here we are using app.root method, we are creating another URL dash webcam. Okay. So whenever just URL user just call this dash webcam URL, the live webcam feed will be on, and user can do the detections on the live webcam feed. Okay. So use app.root method to render the webcam at dash webcam. Okay. And here we are just doing the session.clear as well. So if I have done detections on the live webcam feed and I just refresh the page, so I can do detections on the new live webcam feed as well. Okay. So now using app.root method, I am just creating a front page, or you can see that the page on which can do detections on the input video. Okay. So basically the front page which I am referring is this is basically my front page. Okay. So the page, the HTML page on which we can do detections on the video feed, on input video. Okay. So, okay. So now you can see here, I'm just calling the upload file form, which I have created over here, upload file form. So I'm just calling this over here. So create an instance for the upload file form. Okay. For our uploaded video file. So whenever we upload using Flask form, when we upload a video file, so as I told you, we use Flask form to get input video file from the user. Okay. So our video file path will be saved into this file variable. Okay. So our input video file path will be saved in this file variable. And here you can see that we are using session storage to save video file path. So in the session storage, we basically save the video file path. Okay. So now you can see here, we are just clearing the session.clear. So we are just clearing the session storage using session.clear, so that our previous input video file path is not saved, and when we upload a new video, the detection should happen on the new video. Or if we rerun the application or open the application again, so the detection should not be happening on the previous videos. Okay, so this is the reason we are just creating the session storage, because we have uploaded or we have saved the video file path in the session storage. Okay, so now here we are just creating a URL dash video. So in that, so whenever the user we call this dash video URL, okay, so the detections will be happening on the video. Okay, so as you can see that we have saved the video path in the session storage. So I'm just calling that video path and doing the detections on that video. Okay, and here we have the web app. So basically here I'm just calling the URL web app. So to do the detections on the live webcam feed. Okay, so that's all what we are doing over here. Okay, so this is the web app and everything. So this is our Flask app.py file for this project, for this part of the tutorial. Okay, so I hope you have understood the code over here. So if I just go over here and explain the .html files as well. So this is our basically index project.html is our homepage HTML file. Okay, so now you can see over here we are doc type HTML. This means that we are using HTML, and here I've just defined a language English over here. Okay, and here I've just set the title of my page. So if I just show you, okay, so you can see that this is our home page, and you can see the title object detection dash YOLOv8, which we have passed over here. Okay, and now you can see over here, I'm just setting the body, like what would be the font family of the body, the margin and the padding. Here I'm just setting the margin, padding and font family of the body, and here I'm just defining the header. Background color of the header is black. So let me show you. So now you can see that this is my header, and you can see that the background color of the header is black. Okay, so this is the header. So here just set the background color of the header is black, and the color of the text is being set as white. So if I just show you, now you can see that the color of the text is white over here. The color of the text color is white. Okay, and the height of the header is 120 px, and text dash alignment, like the text will be aligned towards the right side. So now you can see here our text is on the right side. Okay, so and the height of the header is 120 px. We have just set it. And if I just show you, we have set the padding or the margins among these things, like the margins over here, or the padding is we have set is 5px over here. Okay, so now we have just created the second header. So what is, so basically you can see the image over here. This is basically our first header, and this is our second header. This is our second header. Okay, so the background color of the second header is blue. So now currently you can see a background image of the footplot layer over here. So beside this background image, we have the header color as blue. Okay, so we have this behind this image, we have the header color as blue, which we have set over here. And here I've just set the margin top as -30 px, and you can see over here I have just set the background image as set the background image, or the path of the background image which I passed is 1.png. So let me just show you this background image over here. So if I just go to images, so now you can see that this is the image 1.png image which I'm using for the background. Okay, so if I just show you over here, so now you can see that I have just passed the path of the 1.png file, and this is the 1.png file. And you can see here, you can see that this is appearing as the background image because I have set this over here. Okay, and now I'm just setting the background size and other things. And here I'm just setting the list index. So L is stands for list index. Okay, so display inline dash block. So here I'm just defining the display as inline dash block. So as you can see that whenever we define list, they appear in the form of, like, first element we have here, the second element of the list will have here, and the third element of the list will be here. But if we set display inline dash block, they appear in a single line, the block format, which you can see over here. So here I'm using the list index, and inline dash blocks means that home video live webcam will be appearing in the line, like they will not be appearing after 1, 2, 3, like they will be appearing in a complete line over here. Okay, and here I just set the border radius as 10 px. So if I just don't set the border radius, so using border radius, we are just creating a rounded rectangle. You can see now we don't have the rounded rectangle over here. Okay, so if I just set this again, so now you can see that we will have the rounded rectangle over here. So using border radius, we are just creating this rounded rectangle over here. Okay, and here I've just defined the padding and margin, the difference between each of the blocks. And now you can see that whenever we hover it, we get the background color as red. Now you can see here, whenever I hover any of the button, so we get the background color as red. So I have just set here the background color as red, which you can see over here. Okay, so okay, okay, that's fine. So now here we have set the header A color white, text decoration as none, and width at 100%. Okay, so these are just styling. So here we are just doing the styling using CSS. So here you can see the style tag, and here this is all the CSS. This is not HTML. This is all CSS. So I'm just doing styling using CSS. Okay. Okay. Yes. Yes. Right. So all the styling is done here using CSS. You can just check it out. Okay, so now you can see over here, here I'm just defining my three home, video, and live webcam. So whenever the video user will click on the video button, he will be directed towards the front page, which is the video feed page. Okay, so if I just go to flaskapp.py, so now you can see that dash front page will be called, and in this dash front page URL, in the dash front page URL, we are rendering the video project new.html page. So video project new.html is my page, HTML page on which we test on a video. Okay, so here the user uploads the video and click on submit, and the detections happens on the video. So now you can see that when we call the dash front page URL, the user will be, or the video project new.html page will be rendered. Okay, so if I just go to here, index project new, so now you can see here, whenever the user click on the video button, the front page will be called, and the front page URL will be called, and the user will be rendered towards the video project new.html page, which is the page where the user upload a video and the detections happen on the video. And when the dash webcam URL will be called, the user, like you can see here, the dash webcam URL will be called, the user will be directed to the UI.html page, which is our page on which we do the detections on the live webcam feed. So if I just show you, okay, and let me just show from here. So now if I just click over here, so this is the UI.html on which we do detections on the live webcam feed. Okay. Okay, so if I just go here, okay, and here we just write a sample results. We just don't need it currently, like show here. Okay, so now you can see here, if I just go further down here, you can see that we are just defining sample results. So if I just go to home page, now you can see here, we have the sample results. So here I'm just defining sample results, and now here you can see that I'm just displaying three images, sample results images, 1 PNG, 2 PNG, 3 PNG. So you can see that here we have the three images, 1 PNG, 2 PNG, 3 PNG. So these are the images which I am just displaying in the sample results. Now you can see over here, this is my 1 PNG, this is the 2 PNG, this is the 3 PNG, which I am just showing in the sample results. Okay, so now you can see that I have passed the 1 PNG, 2 PNG, and 3 PNG over here. Okay, so now here you can see that here I'm just defining a class and just writing some text over here. So now you can see over here, I've just written some text. So I've written all this text over here in this, okay, part. And you can see that here I'm just passing the 1.png image to display this image over here, which you can see over here, to display this image. Okay. And here you can see that I'm just creating a contact page over here. So this is the contact page which I'm creating. You can see over here. So this is the contact page which I'm creating over here in HTML. And here just defining the footer. So then the user click on this URL, he will be redirected towards my YouTube channel. So you can see that when the users click on this URL, he will be redirected towards my YouTube channel, which you can see over here. So this is all from the home page, which is our index project new.html page. In the similar way, I have just created video project new.html contains the page, HTML page on which you do detections on the video. So this is the same CSS which we have used, and the same thing we have done all over here as well. In the same way, we have the UI.html page on which we do detections on the live webcam feed, and the same style we have used in the style tag. We have just defined CS over here. So for styling, we use CSS. Okay. So in the style tag, I have just defined all the CSS. You can see over here, and you can see we are doing detections on the live webcam feed. Okay. So now let's run this video and see test our now let's run this flask app.py and do the detection on the video and live webcam feed. So I'm just run this flask app.py file. Okay, so just click over here, copy path, and just over here and scan directory and set. Just click over here, copy path, and just click this. And cd means we need to set the current directory and just enter this path. And now we will run the Python flask app.py file, and we will do the detections on the video and as well as the live webcam feed as well. So just run this flask app.py file and let's do the detections on the video as well as on the live webcam feed. So just click over this URL. So now we will be redirected towards our home page. Just remove this previous open URL, all this. So now you can see that we are just redirected to our home page. Okay. So this is our home page. If I just click on this home page, I just click on this home. Okay, so it's giving me error. Let me just check it. Okay, so index project.html. So this is wrong. We need to redirect it towards our home page. So in order to redirect towards our home page, we'll just go over here. Okay, so just add dash home. Okay, so just add dash home over here and click on save. Now just stop this, Control C, and okay, why it's not stopping? Why? Okay, stop. Now run again the flask app.py. So I think it will work fine now. So this might take few seconds. Let's wait and see. Okay, so just click over this URL. Just close the previous two. And now let's check it if it's working fine or it gives some error. So we can correct it if there is an error. No worries. So let's just click on home. Okay, so we will direct it towards this home page, which is dash home. Now click on video. Okay, so now here now you can see that I told you we use Flask form to get the input from the user. So just click on choose file and just pass this bikes.mp4 video and click on submit. Okay, so now you can see that that's wonderful. So now you can see that we are able to do the detections on the video, and here you can see the results. We have done the detections on the video, and here we have the bounding box around the person, bicycle, we have the label person, we have the confidence score as well. So here we are detecting the traffic light, and you can see that we have that label traffic light as well as the confidence score as well. So that's impressive. Like you can see the detections on the video are very impressive. Like our YOLOv8 model is able to detect the bicycle and assign a label and create a bounding box and the confidence score. So now you can see that we have created a bounding box around the detected object. We have assigned the label and the confidence score as well. So now let's test on a video feed. Okay, on the live webcam feed. Okay, so just click on live webcam and see if we are able to do detections on the live webcam feed or not. So let's get started. Okay. So you can see over here, we are able to do detections on the live webcam feed as well. So the detections on the live webcam feed is being done. Okay. Okay. So we are able to do detections on the live webcam feed as well. So it's detecting the cell phone as well. So the results are quite good. And this is the tablet. This is not a cell phone. It's around detection. Okay. So you can see over here, we have created a complete Flask web app and have done detections on the video as well as on the live webcam feed, and the results are quite impressive. Okay, so now you can see that we have created a complete Flask app or complete web app, sorry. Okay, and let me just go further. So now you can see over here, this is our complete web app. We have the home page, we have the video page on which we can do directions on any input video. Plus we have the live webcam feed page as well, on which we can do detections on the live webcam feed as well. So that's all from this part. In the next part, we will see how we can train YOLOv8 model on any custom data and how we can do detections on any custom data set. And we will be creating a complete web app for that custom train model as well. So let's see the next part. Hi guys, in this video tutorial, we will see how we can use YOLOv8 for personal protective equipment detection. So the dataset I will be using in this project is available on RoboFlow publicly. The dataset consists of 3,235 images, and let us show you the dataset. So we have 7 different classes which are marked as 0, 11, 3, 4, 5. We will change the name of these classes. For example, in the class number 0, it's helmet. So we'll change the name of the class 0 to helmet. The class 11, which is the shield. You can see here, the person is wearing a shield. So it's detecting that the person is wearing the shield. So we will change the name of this class from 11 to shield. And in the third class, we can see that the person is wearing a jacket. So we will change the name of this class from 3 to jacket. And plus we can see the class 4, the model is just detecting the mask. So we will change the name of this class from 4 to mask. In the same way, we will change the name of other classes as well. So like in this case, we can see that in the 9th class, the model is detecting that it's the class of boots. So we will change the name of this class from 9 to boots. Okay. So in this way, we will rename all the classes so that when the model detects helmet, jacket, or boot, so we should know that the model has detected a jacket, helmet, or boot. Instead of it shouldn't appear in the detected object, it is 0, 1, 2, or 9. Okay. So we don't want a numeric number. We want the name of the class. Okay. So let's start towards the implementation. But before going towards the implementation, let us see the model health check. So we can see that we have a total of 3,235 images, and we have each image contains around in average 4 to 5 bounding boxes. So in each image, we are detecting 4 to 5 different classes or objects. So we have around 14,341 animation in 3,235 images, and each image contains around 4 to 5 bounding boxes. And the image size is average image size is 416 cross 416, but we will resize the image to 640 cross 640 because our YOLOv8 model is trained on 640 cross 640 images. So it's always better to keep that size. And here we can see that the class balance. So we can see that these last three classes are unbalanced. So that the data set is not very much balanced. You can see that some classes are imbalanced, or you can say that some classes are underrepresented, which include class 4, 6, and 11. Okay, so in the data set, we can see that we have 2,300 images for the training set, 647 images for the validation set, and 324 images in the testing set. So our split ratio is 70, 20, 10. 70% is for the training, 20% is for the validation set, and 10% for the testing set. Okay. So to import this model into our basically Colab notebook, we will click on download and just show down, select the format. So basically we will select YOLOv8 PyTorch because Ultralytics has also basically invented YOLOv8 PyTorch. So if we choose YOLOv8 PyTorch or YOLOv8, it's the same. So just click on show download book and just copy this from here and just click and copy. So now we will just paste this code into our Google Colab notebook. And in this way, we will export this dataset from here into our Google Colab notebook. So before running the script, please make sure that you have selected the runtime as GPU. Okay, now we will click on import OS. Basically import OS because we are using OS to create a helper variable over here. So with that, we can navigate to different files, dataset easily. So just running this cell first. Then we are using glop is used to return all 5 paths. Like if you want the input images 5 paths, we can easily return using glop library. Then we are importing image and display. Basically, we are using these two libraries to display any output image, like predicted output image or any input image into our Google Colab notebook. So to display any output or input image into our Google Colab notebook, we require image and display library. And using display.clear-output function, we are basically this function is used to clear output in the notebook. So if you want to clear output in the notebook, we use clear-output function. Okay, so so we can leave it for now as well because currently we don't have any output, so we don't need this. So in the first step, we need to check whether we have access to GPU or not. So we'll just run this cell and it will show us that whether we are using GPU or not. So GPU memory uses, so that's fine. So we are defining our basically run directory here. So this is our home directory, which is over here. This all is our home directory. So now we will install Ultralytics using pip install. Basically, YOLOv8 can be installed in 2 ways, from the source or via pip. So because YOLOv8 is the first version of YOLO, first iteration of YOLO, which has its own official package. Till YOLOv8, they don't have their own official package. So YOLOv8 has its own official package. So installing Ultralytics, we can install YOLO, and if we use pip install Ultralytics, it will install the YOLOv8 version. So if you do pip install Ultralytics, it will install the YOLOv8 version. So there is another way you can install or implement YOLOv8 is to clone the GitHub repo of your Ultralytics YOLOv8 GitHub repo. So if you want to clone the implement by cloning the GitHub repo, you can also do this. Here is the code written to clone the GitHub repo. So but I will follow the easy way, which is the easy way is used to install Ultralytics. We usually clone the GitHub repo in that cases where we need to make some changes in the code. For example, I want to add the speed estimation in the script in my prediction.py file. So then in that case, I will clone the GitHub repo where I need to make some change in the predict.py or the train.py. In this case, I don't need to make change in the predict.py or the train.py or the validation script. So in the current project, we are not making any change in the prediction script, training script, or the validation script. So we are not cloning the GitHub repo. If I need to add some code in the training, validation, or prediction script, then I will clone the GitHub repo. So I'm using pip install Ultralytics to install latest version of YOLO, which is YOLOv8. So this will install the latest version of YOLO, which is YOLOv8. So it might take some seconds. Okay. So now we will import Ultralytics to check whether our YOLOv8 model installed and it's working fine or not. If it's not working fine, we can see what's the issue, but it's working fine over here. So okay, now we will import the PP detection dataset, this dataset from RoboFlow. So first we will create a folder over here. So one choice is to click on new folder or so create a folder here, but we will create a folder using mkdir and the name of the folder is datasets. Okay, so you can change the name of the folder as well. So now you can see over here, we have a folder by the name of datasets. Okay, this is an empty folder, but we will download the dataset into this folder. Okay, so just seeing what is our present working directory. Now setting the current directory as this datasets folder so that we can download the dataset directly into this datasets folder. So just copy this from here and just remove this and just paste this over here. So now you will be able to download the PP personal protective equipment dataset from RoboFlow into your Google Colab notebook. So the dataset is being downloaded from here. So it might take some time. Okay, so it's downloading and it's around 6%, 7%, because dataset consists of around 3,235 images. So it will take some time to download. So please bear with me until the datasets get download. So it's at 42% currently and 50%, 55, 60%. So in this way, we will download our dataset completely, but it will take some time. Okay, it's 90 and it's 99%. Okay, the dataset is downloaded over here and we can, okay, so if you happen some scenario, then just need to reload this, because if I click over here, a lot of files appear. So I just need to reload it and it will work fine. So don't need to worry in any case. Okay, so just wait for a few seconds and here is our datasets folder and here is our PP detection datasets, which consist of train, test and validation. Okay, and this is our data.yml file, which consists of 7 different classes. Okay, 1, 2, 3, 4, 5, 6, 7 different classes here. Okay, so we just need to do one thing. I have told you that we will rename these classes by their names of the object. So I have done this. So let me upload that updated file, data.yml file over here. So just give me a minute. I will upload this. So guys, you can see over here, this is my updated data.yml file. So you can see that we have a class name against each class, like protective helmet, shield, jacket, dust mask, eye wear, glove, protective boots. So it's not a number, we have a class name against each class. Okay, so we have downloaded the dataset and just checking the dataset location over here. Okay, so basically, if you want to train, validate and run inference or model, and we don't need to do any modification in the code. For example, I don't need to add any speed estimation or tracking or any other script, then YOLO command line interface is the easiest way to do it. So we are currently using YOLO command line interface to implement the training, the validation and testing of our model. Okay, so if you want to do detection, you can stack toss is equal to detect. And if you want to do classification, you can stack toss is equal to classify, or for segmentation, you can stack toss is equal to segment. But we are doing detection over here, so we have stacked toss is equal to detect and mod is equal to train, because we are first training our model. And here we have chosen the YOLOv8 medium model and so on. Okay, so before we start the training, we just need to make few changes over here. We just need to rename this folder and just click on enter over here and just open the data.yml file. Okay, and just open the data.yml file and just go to train and just copy path and just paste it over here and just go to valid, copy this path and just paste it over here. Okay, and just save it. Okay, so just click on Control S. And now we are training our model for 90 epochs and we are taking our image size as 640. And here is our data.yml file path over here, and let's run the training. So first we are downloading our model. So the training will take around 2 to 3 hours, but we will stop the recording and we will be back when the training completes. Okay, so the training has started. You can see over here, the training has started, but it will take quite some time. So we will pause the video as the training gets started. So you can see that the training has started. So as the training complete, I will be back and explain you the rest of the code. Till then, see you then when the training completes. So guys, the training of the model has completed. We have trained our model on 90 epochs with image size 640. And here are the training results we get. So in total, we have trained our model on 90 epochs. So it took around 3 hours for the training to complete. And we have got the best weights file and the 90th epoch last weights file as well. Okay, so we have 7 different classes: protective helmet, shield, jacket, dust mask, eye wear, and glove, and protective boots. So here we got the mean average precision with IOU 50 and mean average precision when IOU varies from 50 to 95% for each of the class. So we can see that we have a very good IOU for all the classes, like it's around 97.8%, 66.1%, and it's 92.8% for the jacket class, and for 96.8% for the dust mask. And IOU, when IOU varies from 50 to 95 with mean average precision. So we can see that here we have also got very good results as well. So we have stored our results into the runs, detect, train to. And here we can see that here is the our weights file. And here we have the F1 curve. To check what different files or results we have in this folder, just run this cell. So you can see that we have the confusion matrix. So confusion matrix basically tell us how our model handles different classes. We have the F1 curve, precision recall curves, and then we also have the recall curve, and then we have the results in the form of CSV. So results.csv file show the performance of the model on each of the epoch. In the results.png, we have the training and validation losses, and then we have the model predictions on the validation batches as well. Okay, so let's first see what the confusion matrix we are getting. So confusion matrix is the chart that shows how our model handles different classes. So if we consider a jacket, for example, so we can see that 92% of the time, our model detected correctly that a person is wearing a jacket, while 1% of the time, we get the bounding box. But the jacket is incorrectly classified as the ideal, while 7% of the time, our model, YOLOv8 trained fine-tuned YOLOv8 model for PPE detection is unable to classify that the person is wearing a jacket, or model is unable to detect that the person is wearing a jacket. So model does not detect anything although the person is wearing the jacket. Okay, so you can see that while 7% of the time when person is wearing the jacket, the model is unable to detect it. So in this way, we can get information from the confusion matrix. Here we can see that 96% of the times our model has detected correctly that a person is wearing a helmet, while 4% of the time when the person is wearing a helmet, our model is unable to detect the helmet. So here we have the graph for the training and validation loss. So we have the graphs of training and validation loss in the results.png. So we can see that the loss value is continuously decreasing. So if we train this model on 200 to 50 epochs, we can get some more better results. While you can see that mean average precision is continuously increasing and recall is also getting better. So here you can see that mean average precision curve is continuously increasing with IOU 50 and IOU 50 to 95. So our results are quite good. So here are the model predictions on the validation batch. So these images are not used for training. So it's always better to have a look. Like here model is just detecting that person is wearing the dust mask. Here the model is detecting that the person is wearing gloves on both of his hands, and the person is also wearing protective boots as well. So the model is working quite fine. Like here is not wear a glove. So here the model has not detected that the person has wear a glove, while the person has here we have been wearing a glove. So model is able to detect that the person is wearing a glove. Okay. So let's validate the model, validate our custom model. So we are taking the best weights which we got over here, best.pt, and we will validate our custom model. So similarly as before, we are using command line interface to do the training. So we are using command line interface to validate the model. So previously we would write mod is equal to train. So here we will write mod is equal to validate, and we are performing detection. So toss is equal to detect. And here we are just passing data.yml file path, which basically data.yml file contains our training set, testing test, and validation test images path. Okay, so here we are validating our custom model. So we can see that we also got very good result in terms of mean average precision with IOU 50 and mean average precision when IOU varies from 50 to 95. So all the results are quite good. So here we are doing inference mean with custom model. So inference means a prediction that we can run on image to detect the label, whether it is classification or a bounding box or a segmentation. So here we are testing model on the test dataset images. So here I pass the path for the test dataset images. For example, let me show you. Here we have the dataset and here we have the test images. So I have just copied this path and just pasted over here. Let me do it again. So here I have just added. So here I have just added the path of my test dataset images, and this is the path of my best weights file, which I am added over here. You can see, and I am not doing prediction, so I am just changing more to prediction. Previously, I was doing validation, so I've written where. When I was doing training, so I was written train, and the task is detect. So now we have been detection, object detection. So I have written detect. Okay, so just run this cell, and it will do test our model on the test dataset images. So it might take few seconds to run. Then we will see what the results do we get. So please wait for few seconds until it runs completely. Then we will see what results we're getting. So the model has run on the test dataset images. So there are 324 images and the results are saved in the predict8 file. As the results are saved in run detect predict8, so just copy this path and just paste it over here. So as we have total 324 images, so we will not display all the 324 images. What results do we get on all the 324 images? Instead, we will only check the results on the first 5 images. Just setting over here. So here to display output on the Google Colab notebook, I have imported from ipython.display import image display. So just run this cell now and see what results do we get. So it might take few seconds, so please wait. So here you can see that our model is able to detect correctly the protected boots, the jacket, the gloves, dust mask, the protected helmet. So results are very wonderful. Here the model is also able to detect the jacket, protective helmet, and here the model is also able to detect the protective helmets, which are all below, the gloves, everything. And here the model is also able to detect eye wear, the dust mask, and the protective helmet as well. So the results of the model are quite impressive. So guys, let's test our model on some demo videos and see how our model performs on the demo videos. So here I am downloading a demo video directly from my Google Drive. So just run this cell. The name of the video is demo.mp4. So it might take few seconds to download. The video is downloaded. So now let's test our model on this demo video. I have passed my best model weights over here. I have set the confidence to 0.25. Task, we are performing object detection and we are doing prediction. And here is the demo video path. So just run this cell and see what results do we get. So it might take few seconds to run this demo video. So because it will process the video frame by frame. So we can see that the model is detecting the protective helmets, jackets, and the frame rate is 27.2 milliseconds. Okay, so it's 70, 80, 90. This is a progressing. We are using GPU, so it's a bit fast than CPU. In CPU, it takes quite some time to training and to do prediction. So it's always better to do test our model on GPU, and Google Colab offers some free GPU as well. So I'm using Google Colab free GPU. Okay, guys. So it might take some more time, although we can see that the model is detecting and protective helmets as well as jackets. So our results will be saved in runs, detect, and train, in the prediction too. And this is our output demo video. Okay, so as this complete. Okay, so our results are saved in runs, detect, predict to. So as our model is file is a bit large, so I think it will not be able to display here. So it's better to download this demo video from here and see what results do actually we get. Okay. So it might take some time to download. So I will pause this videos as it downloads. I will be back and then we will check what the output do we get. I was able to download the demo video and let me play, show you the output. So our model is able to detect the jackets, protective jacket, the protective helmet. You can see that the both person protective helmet and the jacket is detected. Although the model is not detecting the gloves, but the model is able to detect the jacket as well as the protective helmet. So let's test our model on some other demo videos and see what results do we get over there. So here we will download the demo video too and see what results do we get on this demo video. So let me test this our model on this demo video too. Actually, the name of the video is demo 3. So let's run this. So it might take 2 seconds to it execute, but we can see that the model is detecting 2 protective helmets, 1 jacket. Okay, 2 protective helmets, 1 jacket, 2 protective helmets, 1 jacket. It might take some few minutes to run, and then we will download the output, and then we will see what results we get. Our output will be saved in the prediction 3, and this is the name of our output video demo3.mp4. Okay, so I will just download from here. So it might take some time to download. As the download complete, I will be back with the output video. So guys, I was able to download the output demo video and let me play the output demo video. So you can see that the model is detecting protective helmet, jacket. Here also the model is detecting the jacket, the protective helmet. The persons are not wearing the gloves, so the model is not detecting it. So let's test our model on the demo video 3 and see what results do we get over there. Okay. So let's test our model on the demo video 3. So I'm actually not displaying the results over here because these file size are large. So I will not be able to show this output demo videos over here. I have already tested it, so not wasting time trying to show the results over here. So downloading the demo video 3 from my drive directly into the Google Colab notebook. So it might take some time and then I will run the model on the demo video 3 and see what actual results do we get. So it might take some time. So, okay. So model is detecting 2 protective helmets, 1 jacket, 2 protective helmets, 1 jacket, 2 protective helmets, 1 jacket. Fine, that's good. The model is detecting 2 protective helmets, 1 jacket. Okay, so it's total 337 frames we have, and it's currently the model has processed 177 frames. Okay, so 206 frames, 220, 24, 45, 256, 260, 262, 273, 295, and 299, and it's around over. So let me download this output demo video and show you what results we get. The output is saved in prediction 4, demo 4. Let me download this output demo video and then I will back with the results. So guys, these are the results from my output demo video 3. So we can see that the model is able to detect the protective helmet, jackets as well. So this person is not wearing the jacket, so the model is not detecting the jacket, while these 2 persons are wearing the protective helmet, so the model is able to detect the protective helmet and this person jacket. Now let's test our model on the live webcam. Although I'm not wearing a PPE, personal protective equipment, but I want to see if I wear a mask, the model is able to detect it or not. While on the videos and images, our results are very good. So let's test our model on the live webcam in the next part of the video. Thanks for watching. The last video tutorial, we have seen that how we can train the YOLOv8 model on personal protective equipment dataset, and after training or fine-tuning the YOLOv8 model on personal protective equipment dataset, we have tested our trained model on multiple videos, and we have seen that the model depicts a very satisfactory performance, and the model was able to detect the protective helmet, jackets, eyewear, gloves. So now, as we are discussing how we can integrate YOLOv8 model with Flask, so now I will just use the best weights file. So I have just downloaded the best weights file of my personal productive equipment model. So here you can see that here I have the best weights file after training the YOLOv8 model on the personal protective equipment dataset. So this is my best weights file. I will just update this best.pt file with ppe.pt. So I've just updated the name of my best weights file as PPE, because personal protective equipment dataset. Now I'll go back towards the code. So all this code is same that we are discussing already. So what changes I will make is, first of all, previously when we created our Flask web app, so we have used the pre-trained YOLOv8 model. So the pre-trained YOLOv8 model has been trained on Coco dataset, which consists of 80 different classes. But now, as we have trained or fine-tuned the YOLOv8 model on custom dataset, which is of personal protective equipment. So we have seen that our in the personal protective equipment dataset, we have 7 different classes. So I have listed all those classes in the sequence wise over here, which you can see. Okay, and this is here I've just passed the pp.pt weights file, which I have over here. So this is the best weights file, which I have renamed as ppe.pt. Okay, and it is placed in the YOLOv8 folder, and these are the class names or the classes which I have in my PPE data set. Okay, everything else is same, except what I made further change is that previously you can see that for each bounding box we have a pink color. Okay, so and the color of the label rectangle was also pink, but here we have just changed this color. So I have just said that if the class name is dust mask, so if we have a dust mask class, then this color will be assigned to the bounding box as well as to the label rectangle. And if the class is glove, then this color will be assigned to the bounding box as well as the label rectangle. And if the class name is protective helmet, or if the class is protective helmet, then this color will be assigned to the bounding box and the label rectangle. And if there is any other class, like for example, if we have shield or jacket class, then this color will assign to that class which I have given over here. And plus I have set a limit for the confidence score, like the bounding box and will only be drawn around the detected object if we have a confidence score above 0.5. So if we have a confidence score above 0.5, then only we will have the bounding box and the rectangle above the bounding box on which we can put the text. Okay, so that is the change which I made. Else all the ht3 html files are same, and the flask app.py is also the same. There is no change made in the flask app.py file. So let's run the flask app.py file and see what results we got. We will test the trained YOLOv8 model on personal protective equipment dataset on videos as well as the live webcam feed. So let's get started. So I'm just running the Python flask app.py file. Okay, so this might take some time. So let's see. So it might take some time for it to execute. So now I will just click over this link. So it will redirect me to the home page. Okay, so just close one tab because we don't need 2 tabs currently. So now we have the home page. Now let's first test on some videos. So I will just click on choose file, and then I will just go to YOLOv8 crash course, and in the video section I have some videos. Let's first test on this demo video, and just after uploading the video, click on submit. So now we will see if our model is able to detect the jacket, protective helmet, gloves, shield or not. Okay, so let's see what results do we get. Okay, the detections are about to start. So now we can see that our model is able to detect a protective helmet, you can see, as well as our model is able to detect or our web app is able to detect the jacket as well. So now you can see over here, we have detected the jacket as well as the jacket. So although they are wearing gloves, but we are not able to detect it, but we are able to detect the jacket and as well as the protective helmet. Now let's test on another demo video. Let's upload this video and then click on submit and see what results do we get. So this might take few seconds. So now you can see here, this person is not wearing a jacket. So we have not detected a jacket. This person is wearing a jacket and we have a bounding box around the jacket. You can see over here, plus both of these persons are wearing protective helmet, and we have detected that both of these persons are wearing a protective helmet. Plus, although they are not wearing any gloves and shields, so we have not detected any gloves or shield. They are only wearing protective helmets and jacket, which we have detected successfully. So that's impressive. Now let's test our model on the live webcam feed. To test the model on live webcam feed, I will just go back and just click on live webcam from here. And let's test our model on the live webcam feed and see what results do we get from here. So my camera is just going to turn on and let's test our model on the. Now you can see over here, our model is able to detect successfully that I'm wearing a dust mask from here. Okay. So the detection is fine. So as I've been wearing a mask, so it has detected successfully that I'm wearing a dust mask. Thus, I'm not wearing a jacket or a helmet, so it has not detected anything from here. I'm just wearing a dust mask, which it has detected successfully. Okay. So now you can see that we have tested our model on the video as well as on the live webcam feed, and the results are very satisfying. So that's all from this course. I hope you have learned something from this course. See you all in the next course. Till then, bye bye.